Hello and welcome everyone. This is Mohammad Inzamam from Saimedha Ecet Coaching Center, Koti, Hyderabad. Saimedha Koti, Hyderabad is providing free of cost YouTube video lectures for previous Ecet examination questions from the effective faculties of Saimedha Koti, Hyderabad. My dear students, in these video lectures every single day for all the branches EC, EEE, Mechanical, Civil and Computers. For all the branches every single day we are updating PYQs, previous Ecet examination questions. So what are you waiting for, guys? Subscribe the channel and press the bell icon to be notified for the further more updates. Daily update చేస్తున్నాం. My dear students, in the era of where people are making everything as a business, Saimedha Koti Hyderabad is giving the coaching for online Ecet 2024-2025, offline Ecet 2024-2025 కి మనం కోచింగ్ అనేది న్యూ అడ్మిషన్ న్యూ బ్యాచెస్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈ రోజుల్లో where 10th class admissions are going to be for month, effective faculties లో home tuitions కూడా పర్ మంత్ ఎవరైనా సరే 1000 రూపీస్ కంటే తక్కువ అంటే ఛార్జ్ చేయడం చాలా కష్టం. ఎఫెక్టివ్ ఫ్యాకల్టీస్, రెప్యూటెడ్ ఇన్స్టిట్యూట్స్ లో రెప్యూటెడ్ ఎక్స్పీరియన్స్డ్ ఉన్న ఫ్యాకల్టీ మెంబర్స్ తో మీరు 10th క్లాస్ హోమ్ ట్యూషన్స్ తీసుకోవాలన్నా సరే పర్ మంత్ దే విల్ బి డెఫినెట్లీ ఛార్జింగ్ మినిమం 1000 రూపీస్. అలాంటిది in and around for 1 year you will be getting a payment of around how much? 12,000. For SSC home tuition itself, if you are paying 12,000, guys, Saimedha Koti Hyderabad is providing 1.5 year coaching, 2 years coaching, 3 years coaching. Saimedha Koti Hyderabad lo coaching anedi first year diploma nunchi start అయిపోయినాయి, second year diploma students ki start అయిపోయినాయి, third year diploma students ki start అయిపోయినాయి. 3 years course ఉంటది, 2 years course ఉంటది, 1 year course ఉంటది. అలాంటిది టోటల్ కోర్సెస్ కూడా ఎప్పుడు మన దగ్గర ఫీజు అనేది 10,000 దాటలేదు. అందులో కూడా మళ్ళీ మెరిట్ పెట్టి పర్సెంటేజెస్ వైజ్ కన్సెషన్స్ పెట్టి ఎకనామికల్లీ బ్యాక్వర్డ్ ఎవరైతే ఉంటారో వాళ్ళని ఎంకరేజ్ చేయాలనే ఉద్దేశంతో మినిమం ఫీజెస్ తో మాక్సిమం కన్సెషన్స్ తో సాయిమేధ కోటి హైదరాబాద్ ఈస్ ప్రొవైడింగ్ ఎవ్రీ ఇయర్ కోచింగ్. రిజల్ట్స్ విషయానికి వస్తే యు నో ఇట్ గైస్, ఎవ్రీ సింగిల్ ఇయర్ టాప్ 5 బ్రాంచెస్ లో స్టేట్ ఫస్ట్ ర్యాంక్స్ తో పాటుగా మాక్సిమం ర్యాంక్స్ వాస్ సెక్యూర్డ్ బై సాయిమేధ కోటి హైదరాబాద్ ఓన్లీ. So my dear students, what are you waiting for? Ecet 2024, Ecet 2025, Ecet 2026 coaching has been started in the Saimedha Koti Hyderabad. Effective coaching ఎక్కడైనా ఉంది, మనకు ఎక్స్పర్టైజ్డ్ ఫ్యాకల్టీస్ నుంచి ఎక్కడైనా కోచింగ్ ఉంది, డిజిటల్లీ రికార్డెడ్ వీడియో క్లాసెస్ ఒక సిస్టమాటిక్ ప్యాటర్న్ లో కోచింగ్ వీఆర్ ప్రొవైడింగ్ బోత్ ఆన్లైన్ అండ్ యాజ్ వెల్ యాజ్ ఆఫ్లైన్. సో వాట్ ఆర్ యూ వెయిటింగ్ ఫర్, గైస్? Download the app saimedha.in and press the bell icon to be notified for the every updates. Every single day we are going to be updating in the YouTube channel. Subscribe the channel, press the bell icon to be notified, download the app saimedha.in and scrolling on the mobile numbers ki contact journey and join now in Saimedha Koti Hyderabad. At the end of the video I'll come back one more time for some more information. Till then, guys, watch the video now.
Let us see the next question over here. A simply supported beam of span length 2 meter is carrying a uniformly distributed load of intensity 300 Newton per meter. Okay, we are having some options over here. The maximum shear force is 300 Newton. The maximum bending moment is 150 Newton meter. The maximum bending moment occurs at the mid span. Okay, so first let us try to diagram what we are having over here. Simply supported beam. If you are having simply supported beam, so this part we have taken, this is simply supported beam. Okay, now next point, length, how much we are having over here? 2 meter. So length, this complete length we are taking it as a 2 meter. This part is 2 meter we have taken. Is carrying a uniformly distributed load. Now we are having uniformly distributed load over here. Okay, this uniformly distributed load, UDL. How much we have taken? UDL means how much we have taken over here? 300. This is 300 Newton per meter. Okay, 300 we have taken it as a UDL. Now we are having some options over here. So first let us go with this part, what we are having. So let us take this point as A we have taken, this point is B. So this is RA, we are calling it as RA, this is RB we have taken, and somewhere in the middle we are taking it as a point C. Okay, so already we have discussed this question in detail. We have written in detail over here. So what we are getting this part. So maximum shear force, what is the shear force we are getting? First let us try to calculate RA value and RB value. RA value, it is equals to RB value because we are having UDL. If you want to convert that UDL into point load means it will be in the middle of that part. So RA is equals to RB is equals to what we are having over here, W into L. W into L means what we are having, 300 into L divided by 2. W into L by 2, that is for UDL part. Okay, Or else if you are having simply, we are having central point load means what we have to take, W by 2 we have to take. So over here as we are having this 2 gets cancelled, it is equals to 300. What we are having? 300 we are having over here. Okay. Now let us see this part. So RA is equals to RB is completed. But whenever we are calculating the shear force, okay, if you are calculating the shear force over here, listen carefully. This part, shear force at point B, it is becoming minus 300. It is becoming what? Minus 300. Because if you are drawing the imaginary line over here, it is coming under quadrant 4. Quadrant 4 means what we have to take a negative. Quadrant 1 and quadrant 3 will be positive, but quadrant 2 and quadrant 4 will be what? Negative. So this part we are getting it as minus 300. And we have taken some section over there. In the previous question we have done in detail about that part. So shear force at point C we are getting it as 0. Then shear force at point A it is equals to RA. Okay. So shear force at a point A, it is equals to RA, which is equals to 300. Okay. So this part we have taken over here. 300 newtons means the option A is correct. Now next to what we are taking, the maximum shear force occurs at the end span. End span means we are not calling this part end span. Let us go for maximum bending moment. Now what is the formula for maximum bending moment over here? So bending moment what we are having. So already as we have discussed, bending moment at a point A, it is equals to bending moment at a point B, it is equals to 0. Now at the supports, whatever the supports we are taking over here, so this bending moment at point A and bending moment at point B, directly what we can write the answer 0. But bending moment at point C, it is equals to, means shear force at point C, it is becoming what? 0. So whenever the shear force is becoming 0, bending moment is becoming what? Maximum. Okay, means we have taken that case over here. So bending moment at point C, we have to remember that formula. We are having this part as WL square by 8. Okay, what is the formula we have to remember? WL square by 8. Now what is the W value we are having? W means 300 we have taken over here, 300 into, now L means what we are having? 2 square means 4 divided by 8, 4 ones are 4 twos are 2 ones are 2, 150 is equals to 150, okay, Newton meter. What we are getting over here? 150 Newton meter, means whatever the maximum bending moment we are having, it is equals to 150 Newton meter. So this option C is also correct. Now next to what we are having, the maximum bending moment occurs at the mid span, because where we are getting the shear force over here, if you have taken the point C, at that point C, we have taken at that point C, shear force it is becoming 0. So if the shear force it is becoming 0 at this point C, at that point only we are getting bending moment as a maximum, means midpoint. At the midpoint we are getting maximum bending moment. So point D is also correct. So ACD, suppose if you are going with ACD over here, what is given? BC, only BCD is given, CDA is given, A option, D option and C option, means second. Okay, second option is correct over here. Now we have to find out only the force value we have done, bending moment value we have done. Okay, now let us go for the next question. The bending moment for a particular beam is expressed as, okay, now listen carefully. We are having some bending moment value, some bending moment equation we are having over here. What is the shear force at x is equals to 0.3? X is equals to 0.3. Now what we are having means we are having one relation over here. We are having the relation between shear force, bending moment and the rate of loading. What is that relation we are having means whenever we are differentiating moment, what we are doing over here, whenever we are differentiating moment d by dx, okay, d by dx. So whenever we are differentiating moment, we will be getting what? A shear force. What we are getting? Shear force. Okay, over here also what we are doing over here, whatever the bending moment is given, if you are differentiating this part, we will be getting what? A shear force. Okay, again if you are differentiating shear force, then we will be getting what? Rate of loading. Okay, like that we have to remember. These are the relations we are having. If you are differentiating bending moment, it is equals to what? A shear force. If you are differentiating shear force, then it is equals to what? A rate of loading. So let us differentiate this, what we are having. So this part, if you are differentiating moment, it will be what? A shear force. shear force it is equals to 600x we are having. So d by dx of x means what? D by dx of x means 1. So over here we are getting 600. This is 600 we have taken. Now if you are multiplying with this minus 500x, minus 500x means again d by dx of x means what? 1. Means we are having minus 500 over here. Okay. Now minus into minus plus 500 into 0.2 we are having, means numerical value. D by dx of constant will become what? 0. Okay. So for this numerical value we are getting the answer as 0. Now next part, minus we have taken. Now x square will become what? 2x. D by dx of x square means what? 2x. So 2 into 300. 2 into 300 means what we are having? 600x. Okay. So this is shear force. But we are not getting any exact value over here. So what we have to do means this x value is given, x value, that 0.3 we have to substitute over here. If you are substituting 0.3, let us see this part what we are getting. So 600 minus 500. 600 minus 500 means what we can take over here? 600 minus 500 means 100 minus 600 into 0.3. Okay, this part we have taken. Now we have to multiply this part. If you are multiplying means what we are getting over here? 600 into 0.3 means 18 we have taken. Next what we are having? 000. Okay, means we are getting the answer as 1800. Means after one number we are having the point, means we have taken 1 point over here. Okay, so it is equals to 100 we have taken minus this part we are getting it as what? 180. 100 minus 180 means what we are getting? Minus 80 newtons. Okay, so simple concept we are having. Whenever the bending moment equation is given, we have to differentiate that part. If we are differentiating, we are getting shear force, but we have to substitute x value also. So we are getting the answer as what? Minus 80. Okay, so third option is correct. Third option, minus 80. Now next one, the point of contraflexure. Again the question repeated over here. The point of contraflexure lies where the shear force changes sign, bending moment changes sign, shear force is maximum, bending moment is maximum. Means what is the answer we are having? Bending moment changes sign, then we are calling it as what? Point of contraflexure. Okay. Now next part, a simply supported beam of length L carries a uniformly distributed load W per unit length. Find the bending moment at x is equals to 0, x is equals to L by 2, x is equals to L. Already we have discussed this question over here. Suppose just now also we have taken, if we are taking simply supported beam, this simply supported beam we have taken, and we are having length L carries a uniformly distributed load. This is uniformly distributed load we have taken. Uniformly distributed load like this we have taken. So this is RA and this is RB. So and if you are taking this part as W and this complete part we have taken it as L. So RA is equals to RB is equals to WL by 2. Okay, like this we have taken. So RA value, RB value is equals to WL by 2 we have taken. Now next what we are doing means, listen carefully. So at this point, suppose at this point we are taking it as a point C. So if you are calculating the shear force values, shear force at a point B, shear force at point B means, now listen carefully, this we are having. So if you are drawing some imaginary line over here, if you are drawing imaginary line, it is coming under what? Fourth quadrant. If it is under fourth quadrant, what we have to take? Positive or negative? Negative. So we have taken negative over here. Minus we have taken, and what is RB value we are having? Minus WL by 2. Okay. So shear force at point B it is equal to minus WL by 2 we have taken. Now next part, directly we go for shear force at point A, which is equals to RA, which is equals to WL by 2. Okay, this part we have taken. Now if you want to calculate shear force at point C also, if you are calculating shear force at a point C, then it is equals to, already we can write that part, what we are having? Minus WL by 2, minus WL by 2. Now at point C we are calculating. At point C means let us take this distance as L by 2 we have taken. If you are taking this point, what is the load we are having? W into L by 2. Okay, area, length into breadth means W into L by 2. If you are considering this complete UDL means we have taken WL. But if you are taking up to point C only, we have to take W into L by 2. Okay, so we are taking this part as a plus WL by 2, which is equals to, because these loads are acting downwards over here. So if you're drawing some imaginary line for this, it is coming under first quadrant. So we have taken plus over here. WL by 2, WL by 2 means 0. So these are the shear force values we are getting over here. Now actually we have to calculate bending moment values. So already, as I have told you, bending moment at point B, it is equals to 0. Bending moment at a point A, it is equals to 0. Okay, this part we have taken. Now we have to calculate a bending moment at a point C. Okay, now listen carefully. Now we have to calculate a bending moment at point C. Means first we are taking this part. So it is positive or negative. As it is moving upwards, means smiley face we have taken. So positive we have to take. So what we are having over here, WL by 2, WL by 2 into, what is the distance we are having? Distance is L by 2. So we have taken L by 2. Okay. Now next part. If you are converting this, now listen carefully. If you are converting this is RB we are having. Let us take over here. Let us take over here. This is RB. This is RB we are having over here. And we are converting that UDL into point load. Okay. This point load we have taken. And what we are having over here, this part, this complete length up to this point C, this is point C we are having, this is L by 2. But as we are converting this, this will become what, L by 4, and this is also what, L by 4. Okay, this part we have taken. Now this RB we have calculated, and whenever we are converting that UDL into point load, UDL into point load means what we can do over here, this W into what we are having, L by 2, WL by 2, this point load we have to take over here. Now next, let us take this one. So if you are taking this one, we have to take it as minus. Okay, we are taking it as minus because this load, it is acting downwards, means it is becoming some sad face over here. So we have taken minus. Now up to point C, what is the moment we are having? Force into perpendicular distance. What is the force we are having? WL by 2 into, then what is the distance we are having over here? L by 4. So which is equals to WL square by 4 minus WL square by 8. Okay. Now if you are simplifying this part, what we are getting the answer? The LCM will be 8 only, and the numerator will be WL square. So what is the answer we are getting over here? WL square by 8. Bending moment at point C is equals to WL square by 8 we have taken. Okay. So over here also what we are getting the answers now. A simply supported beam of length L we have taken carries a uniformly distributed load W per unit length. Find the bending moment at X is equals to 0. X is equals to 0 we have taken, and X is equals to 1 we have taken. X is equals to 0, X is equals to L. Means answers are 0, 0. At the middle, X is equals to L by 2. If you have taken X is equals to L by 2, what is the answer we are getting over here? WL square by 8. Means which option will be correct? 0, WL square by 8, 0. Fourth option. Okay, fourth option is correct. But directly you have to remember this answers whatever we are getting over here. Shear force at point B, shear force at point A, and shear force at point C for this diagram it is equals to 0. Bending moment at point A and point B it is equals to 0. Bending moment at point C we are getting the answer as what? WL square by 8. Now next, variation of the bending moment in cantilever carrying a load intensity of which varies uniformly from 0 at free end to W per unit length at the fixed end is given by. Okay, so linear, cubic, constant, parabolic. So what we are having over here, variation of the bending moment, in cantilever. If you are having uniformly varying load, which load we are having? Uniformly varying load we are having. So what we are getting, the bending moment diagram. Okay, so just now as we have taken this symbols over here, let us check this part. So what we have taken over here, see this one. So whenever we are having uniformly varying load, if we are having uniformly varying load for bending moment what we are having? Cubical. We are getting the figure like cubical over here. If it was shear force, then we can go for what? A parabolic. But bending moment, if it is asking in the question, means we have to go for cubical part over here. Cubical means we can go with the second option. Okay, so it will be what? A cubic. Second option is correct.
So thank you very much guys for watching this video till the end. Definitely this video has been improvised your subject knowledge and definitely given you an idea about how the previous Ecet examination question is getting up here. Again one more time guys, ee video ni meeru nachite kachithanga like cheyandi, share cheyandi, subscribe cheyandi and press the bell icon to be notified for the further more updates guys. Admissions అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈసెట్ 2024, ఈసెట్ 2025, ఈసెట్ 2026 ఫస్ట్ ఇయర్ వాళ్ళకి, సెకండ్ ఇయర్ వాళ్ళకి, థర్డ్ ఇయర్ వాళ్ళకి ఆల్రెడీ ఈసెట్ కోచింగ్ అనేది ఆన్లైన్ కోచింగ్ అండ్ ఆఫ్లైన్ కోచింగ్ new batches is going to be started guys. So my dear students, what are you waiting for? Download the app saimedha.in. మీకు ఏ డౌట్స్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి. Join now in Saimedha Koti, Hyderabad. Thank you very much. This is Mohammad Inzamam signing off.